Finally, the last two terms you need to know before we even get started are compile and run. Compiling and running are two things we do to code to see if it's working the way we intend. Compiling is like reading over code and looking for errors in the way we've written it. It's kind of like the proofreading you would do on an essay. You can just look at the text and see if there are problems with it, like misspelled words or comma splices. Code is more complicated than an essay though, so we rely on computer programs called compilers to do this for us. They read in the code and let us know what problems they find. If there aren't any problems, they produce programs that we can then run. Running is when the program is actually executed. Just because some code compiled into a program doesn't mean it'll actually do what we want it to do. It just means that what we told it to do makes sense. So for example, imagine we wrote a program that would add two numbers, but we accidentally used a subtraction sign instead of an addition sign. The code still makes perfect sense to the compiler, it just does the wrong thing. So to use an analogy, imagine giving your friend directions for where to find a form in your office. You write the directions on a piece of paper and you hand them to her. She reads over them and checks to see if they make sense. Perhaps she can't read something that you wrote, or she wants extra clarification on a particular step. That's like compilation. She checks to see if the directions make sense before actually trying to carry them out. Then, when she's satisfied with them, she tries to actually do them. That doesn't guarantee she'll be successful though. Maybe the form isn't where you said it would be, or maybe one of the steps made sense on paper, but doesn't make sense when she's in your actual office. That's like running the code, actually carrying out those steps. Now it's important to note that this description of compiling and running is from the perspective of how you write code and build programs. In reality, compiling code actually serves a more significant set of purposes than what I've talked about here. Compiling translates the code that you write into low-level types of commands that the computer can actually understand. That level of detail is outside the scope of an Introduction to Computing class, however. For the programming that you'll actually do, this definition of compiling and running should be fine. Now you might also notice that compiling seems potentially optional. After all, your friend could go and try to follow your directions without ever reading them first. Compilation is more important under the full definition of what it includes, but you're right that it could potentially be skipped. We call languages that require compilation static or compiled languages, and languages that don't require compilation dynamic or interpreted languages. Nonetheless though, even with dynamic languages, we often mimic the workflow of static languages. You likely won't encounter the difference between the two until much later in your computing studies though.